ask her, but I can find out and post that. I'm sure it was free. You by no means need to use this. It's just that this is what the most convenient thing a lot of us have. Sorry, go ahead.
So we were making a histogram.
We're going to.
Standard deviation.
From our data, from the data itself.
But not the raw data.
We are.
Oh.
But here's the deal. This seems a little weird. What Serenity is troubled with is the fact that, okay, you just told me we're not going to have the raw data.
Right.
Or we're going to build a histogram off the raw data. Here's the deal. The researchers have the raw data.
Right, oh, okay.
They're going to be giving you an image of it, and most likely that too, and then your job is to decide some stuff in lieu of the raw data, what you still can pull.
Gotcha.
Is that fair?
Yes.
It's a little ficticious because I'm giving you raw data and saying, pretend you don't see it. But in 9 times out of 10, you're not going to see it. Or even more than that, 9 times, or fewer than 9 times out of 10.
I just don't see where like the 16 comes into play because.
5 minutes.
Okay.
I promise you, I swear. When it becomes visual, it's like, oh God, there it is. I swear to God. And it's going to tie back to the 75% as well.
Okay.
It pops right up as soon as you make it visual and two-dimensional. It's like, oh, okay, now it makes sense. And the idea of it is the definition of standard deviation, average distance. What it does is it ignores the weightedness of that average. There's a weighted average going on with that standard deviation that you don't notice right now because the raw data is too hard to look at. But as soon as you see a graph, you're like, okay, now it makes sense. Promise. 4 minutes now, please.
Can you make a histogram out of this? Sarah,
Sarah, go ahead. Can you
make a histogram out of just this data, or does it have to be?
You can do it both ways.
Oh.
We have tricks.
Okay.
Yeah, now you do have to make certain assumptions on the data when you lose the rawness of it, but you can still pull a histogram as long as you set it up properly, which we're going to learn how to do right now.
Awesome.
Good questions, good questions. Fire them up! Fire them up. Let's make sure we can see this on the film. Just call it film, how cute. Child of the 80s I am. All right. Okay, so fire them up. You got your data in your list 1, I'm assuming. So, or your cell phone, that works too. So, the first thing you want to do is you want to go to your plots menu. The way you do this is you press your second button, second function button, which is your shift key, and then press the Y equals button on your machine.
After you have everything in your list, right?
You gotta have your data in first, otherwise you're gonna get an error on this. See, so you put your data in, ready to go, and now we can take a look at what the data actually looks like. Go ahead, Corbin.
How do I do that on a TI-89?
I'm gonna say the same thing I said to you roughly this time 48 hours ago. Give me 5 minutes after class. Because I don't remember. I know once I see it, I can do it. I just don't remember it. So give me 5 minutes and just play. I mean, it's gonna be similar to this, honestly. I just can't remember the menu. We just, you know, we're behind for half an hour. You're going to go to plots, F2. Boom, plot setup. And then F1 define. And then you have to take right here. Cool, and I think it's going to be pretty similar from here on in. If not, we'll fix it after class, I promise you, friend. Good? We're here. Grab plot 1 by pressing enter, or 1. Turn that bad boy on by pressing enter. Now, I got a feeling most of your TIs look like this right now. This is the default setting. It's set on scatter plot. It's fine. We want to get it from scatter plot to histogram. So scooch over to the one that's shaped histogram-ish like bars and press enter. When you do that, this down here changes a little bit. Does your TI say L1 for X list and a 1 for frequency? That's the default. If anybody's not say that, cool, just says something different. You might not have to say that in yours. Try leaving everything else exactly the same and see if it works. If not, I'll run back there and play with it. Okay, we're good here. We are now set up to make a histogram. One thing you should always check, just because it's a minor annoyance, press the Y equals button and make sure nothing's in your Y1, Y2, Y3. Sometimes we store equations in there and they just get in the way. So make sure they're all clear or turned off. You can also turn them off so you don't lose them. Okay, now as soon as you enter data and you turned on your plot, the easiest way to see it is to press the zoom button. The zoom button is top row, right in the middle. Press that zoom button. There's a bunch of presets in here. The nicest one is the 9th one, which is called Zoom Stat. What this does is, it opens up the TI window to draw a rectangle around your data and the histogram, so you don't have to worry about figuring out where the lows and highs are. So just press zoom and then 9.
How did you get to zoom?
Just press the zoom button, top row, middle button. Press that zoom button and then press the 9 numeric key.
Oh, my frequency's off.
What does it say, L2?
It says CU.
ZU? That's very interesting. Hang on. So right here it says ZU.
Yeah.
Okay, here we go. Arrow down to it.
Okay.
Arrow down to it. Now notice when you arrow down, the cursor has a little A on it. That's a bug TI refuses to fix. So take it out of alpha mode by pressing the alpha button.
Okay.
And now just press the 1 key.
Oh, thank you.
There you go. Now you're golden. Yeah, if this is going to happen to us a lot in this, we're going to be messing with these quite a bit. We're going to be changing these, changing lists, and whenever you change lists, for some reason, I don't know why, but when you go to the list, it's in alpha numeric mode, or alpha mode, which means you have to turn it off first and then enter what you need. I don't know why, it's just one of those things.
Because I enter blood and it
I know,
Y.
it comes up as Y, exactly, because Y is 1, yeah, exactly. So anyway, we getting histograms? Corbin, did it work for you or no?
It did, but then I went to zoom, and then went
Hey,
away.
they went away?
Hang on.
Let's take a quick peek.
Can I just start now?
Okay, you got your data, so F2 plots, plot setup. Good. You're gonna find.
That's what I did.
One variable, okay, so something's goofy. Get back to that data sheet, let's take a look at it again. Alright, friends, now, what I like to do at this point, I like to finagle. Here's why. The TI is always going to draw the same kind of histogram at this point. It's going to take your data range, and it's always going to put 7 bar spaces. Maybe not 7 bars, but it's going to divide your data into regions that are 7 wide. Why 7? I don't know, because they decided that was the number they were going to use. I don't know better explanation than that. Here's why I don't like it. Press the trace button. When you press the trace button, it puts what I like to call lovingly the spider onto your bars. You might remember this from your Math 111, Math 95 days. The spider gives you some information because the TI doesn't do things like label the axes. You have to label it yourself, essentially in your mind. So what this tells you is this bar, the smallest value on this bar is negative 58. The highest value is negative 44.8 and some change. And there is one data point between those numbers. Now you have the raw data, you know it's negative 58. But in lieu of raw data, you'd have to pick the point halfway between these two numbers. Which gets to be annoying, doesn't it? Because that's an ugly decimal and that's 58. If you scooch over one more, when I say scooch, I just mean go right and left. So scooch to the right. This bar goes from negative 44.8, which was the previous high point, is now the low point, up to 31 2/3, negative 31 2/3, and there are 3 data points in that bit.
Oh, I like what it tells you.
I like that too. I wish it called it F and not N. That's the only, why would I wish it called it F and not N? Frequency versus a sample size. And all statisticians use N as a sample size, and here they're calling it, but whatever. I like it too, so I think it's great. I think it's great. What I don't think is great is this. These numbers are annoying to me. Well, we can change it. That's the best part. Press the window button, which is just left of zoom. Just left of zoom. Window. Pick more logical values that still contain all your data. Negative 58, for example. Why don't we make it negative 60? That's like a more logical value, wouldn't it be? Like round it down, negative 60. All right, negative. Make sure you use the negative button, not the minus button. It gets pissed if you use the minus button instead. X max is 34.166666. What should we call that? How about 35? Look at the X scale, FYI. X scale you might remember from back in the day, your Math 111, Math 95 classes. This is how wide the bar is. Why make the bar 13.166 wide? That seems kind of silly. Well, it's 1/7 of the range of the value that was in the data. So pick something more logical. What do you think? About 10. I love it.
Wait, I'm confused though. Why is your X max 35?
Because it's big enough to contain all the data, but now it's a normal, a multiple of 5 or multiple of 10, some nice quote-unquote number.
So is this, because the biggest amount of people gain is 800.
Right, but here's the kicker. Oh, the biggest they gained, I think it was 21, wasn't there?
No, it does.
Oh,
Okay, so Serenity's got a point. Maybe if we knew the largest value was 21, maybe we should just go like 25 instead of
Yeah.
35. How about that? How about
Okay.
25? Good. No, there's nothing wrong with going to 35. Whoever said that, it would just be blank space over there. Totally fine.
So
But
just choose this 235?
it shows one reason to go to 34,
Yeah.
and we bumped up to 35. That's
Okay.
fine. You can also make it go to 30, and then scale it by tens. That might be even easier. But you have some choice here, is what I'm saying. And watch, we're gonna finagle with this as we go with the rest of this day. So you made this 10. I think is what I heard from folks. 10.
Yeah.
Okay, good. Now the Y mins and the Y maxes in this class should be called F mins and F maxes. Really, that's the frequency of the could be. I like to leave a little bit of space under. So Lauren's got a good point. You might as well call Y min 0. If you do that, nothing wrong with doing that. It just puts the horizontal straight flat at the bottom with no space, and that's totally fine because the TF doesn't give you a label anyway. So you can call it 0. As far as the max of 14.04, I don't even know if that makes sense anymore. It may have to change based on our groupings. We can hit graph and find out in a second. This is kind of dumb. I don't know why it set it to a scale of 0.1. Why don't we make it 1?
Now, your Y max, wouldn't you want that to be the amount of people in the total study?
Not necessarily, because all those people would be in one bar.
Right.
They're spread across a number of bars.
Okay.
So how many bars are we going to have now? Out of curiosity, how many bars are we going to have? 60 to 50, 50 to 40, 40 30, 30 20, 20 10, 10 0, 0 10, 10 20,
Right.
8.5. Maybe we should make that 25 to 30.
That's where I was going.
Maybe make 25 to 30, that way we don't have half a bar to deal with, if that makes sense. You see what I was doing? You see how I was counting my tens? That's what this is telling me to do. And finally, when you're happy with how you set it up, press the graph button, which is the only button in the top row you haven't pushed yet. You've pushed everything else except that one. Press graph, and there's your new histogram. There's your new histogram. See, I feel better. We preemptively avoided an issue with this. Originally, when the X max was at 25, we cut that bar in half. We lost half the bar. So by pushing it out to 30, we actually see that bar again. And
Yeah.
how is it different than the previous one?
It's not a bell curve.
Say it again.
It's not a bell curve, it's by modal.
What? Well, good,
I
good.
mean, not being.
This is a very, very good statement I'm hearing over here. She says it's now bimodal where it wasn't bimodal before.
It's not bimodal, but technically, right, because there's not two high points that are equal.
I love this discussion. So the question, we learned about this phrase bimodal last time, 2 modes. It's got a secondary hump, kind of like a camel, if you will. But the question is that hump meaningful or is that just random chance? We don't have an answer for that yet. No answer for that yet. I did hear the word bell curve pop up. Did everybody catch that? Is everybody thinking this is maybe like a bell curve-ish? The previous one might have been a bell curve-ish as well. And this is the beauty of technology. Watch this. Go back into your window. Change the scale to some different numbers. Change it, say, to 5 instead of 10, and then regraph. Take a look at a few different windows. See if a different window shows you a different look, or if something is remaining consistent. What seems to be remaining roughly consistent as we change the scale, oops, that was the wrong one. As we change the scales on these things, what seems to be roughly staying the same? The overriding shape of the data looks to be about a bell, doesn't it? Looks to be about a bell shape. Now, any of those windows I just did, any of them, you guys like any of them better than others? That's 15 wide. Here was 10.
10 was pretty good.
10's pretty good? What's the worst thing with 10? I'm totally down with that. Totally fine. Totally fine with that. Love it. Great. No one window is correct. They're kind of all correct, if you will, if you want to think about it that way. Okay, I'm going to pause this and then start it up again.